last video cut off on example 1 on letter C, and here if you'll notice, we're going to multiply -5 to the first power, and then -5 to the 6th power, which was -5 to the 7th power. So what I was going to tell you is anytime I raise a negative number, and the negative's inside the parentheses to an odd power, then if I work it out, my answer is going to be odd as well. Had this been an even number, such as 6 or 10 or 20, then it would be a positive. So anytime we raise a negative number to a positive exponent, then it will be positive. And then D, we have like basis, so it's going to be x4 plus 3, which is x2 to the 7th power. Now that is the power of a product property. Now, I want us to look at the next property that we have, and this is the power of a power property. If you'll notice here, we have a to the 2nd power raised to the 3rd power. This is the same thing as saying a to the 2nd times a to the 2nd times a to the 2nd. We know we would add those exponents because they're like basis to get a to the 6th power. So, we have the example a to the n power raised to the n power. You multiply m times n. Okay, so if we have 3 to the 4th power raised to the 2nd power, that's going to be 4 times 2, or 3 to the 6th power. So now let's look at the examples that go along with it. Here we have, in example 2, 2 to the 5th power raised to the 3rd power is going to be 2, 5 times 3, or 2 to the 15th power. Okay, now notice here we have -6 raised to the 2nd power times 5 would be -6 to the 10th power. Now in this case, if I evaluated this, it would be a large number, but it would be positive because we're raising it to an even power. Now our next example, we have x squared to the 4th power, so we're going to say x2 times 4, which would be x2 to the 8th power, and then we have d, y plus 2 to the 6th power times 2. Now notice we have an entire polynomial in here, and we're going to keep it intact. So we're just going to keep it in the parentheses, y plus 2, 6 times 2, and that would be y plus 2 to the 12th power. And we would just leave it like that. Now, the last property we're going to deal with here is the power of a product property. This is when I have 2 or more values inside the parentheses, and then we're raising it to a power. Everything in the parentheses will get raised to that power. So in this case, we would raise a to the n power and b to the n power. So like for instance, we see here we have 23 times 17 to the 5th power. So we're going to raise 23 to the 5th power times 17 to the 5th power. Now if I evaluated this, I'm going to get a really large number. But we're just simplifying here. So let's look at the examples in example 3. Here we have 24 times 13 to the 8th power. So it's going to be 24 to the 8th power times 13 to the 8th power. Okay? Then we have B. 9 squared is 81. That's pretty reasonable, pretty easy to answer, so I'm just going to write out 81. X squared, y squared. Now notice with Z, we have -4z squared. Because the negative's in the parentheses, we're squaring it as well. And what happens when I square a negative number? It becomes positive. So that will become positive 16z squared. Now with this one, the difference is our negative is outside the parentheses. So we're not squaring the negative. So we're going to keep that negative and then square everything in the parentheses. So that's the difference between the two. Now the last problem that I want to call your attention to is actually example 4. Let's take a look at that one. Here we have 2x to the 3rd squared. Now what we're going to do, and then it's times x to the 4th. So let's work that one out. Here we're actually using the power of a power property, and then we're going to use the power of the product property in order to solve this. So I'm going to use the power of a power, the power of a product, so we're going to say that would be 4x, 3 times 2, x to the 6th times x to the 4th. Add your exponents. 6 plus 4 is 10, and your answer would be 4x to the 10th. Now, also, it helps us to use exponents for order of magnitude problems. Magnitude problems are problems that involve really large numbers. And, you know, it's easier to use exponents than it is to write out problems. Like, for instance, there's 91,000 species of insects, if I want to express that to the closest power of 10, we would say that is 100,000. So we would say 100,000 species, but suppose we're gonna work these in a problem, it would be easier for me to say 1, 2, 3, 4, 5, 10 to the 5th power. So we will deal with order of magnitude problems using the exponents just because it's easier. Let's look at example 5 on page 491. It says in 2003, the U.S. Department of Agriculture collected data on about 10 to the 3rd power honeybee colonies. In each colony, there are about 10 to the 4th power bees. During the honey production season, about how many bees did we study here? Well, we know we have 10 to the 3rd power colonies, and in each colony, we have 10 to the 4th power bees, so we know we're going to have to multiply here. So it's as simple as saying 10 to the 7th power. Now that's the equivalent of 10. 1, 2, 3, 4, 5, 6, 7, 10 million bees. But you can see it's a lot easier to work with exponents than it is to have to work with these large numbers. Okay? And we will work the guided practice in class.